You know, the AI race is entering this strange, completely fascinating new phase. For years now, literally the entire tech world has been totally obsessed with the models themselves, right? We were all endlessly tweaking prompts, just trying to get the AI to spit out the perfect answer in one shot. But honestly, that era, it's kind of ending. Today, the absolute biggest players in tech are obsessing over a hidden architecture called harness engineering. And let me tell you, it is the invisible secret behind actual real-world enterprise AI adoption.
To put the stakes into perspective, $7 trillion. That's with a T. Back in 2023, Goldman Sachs dropped this massive macroeconomic prediction. They said generative AI could add nearly $7 trillion to the global GDP over the next decade. I mean, it's the ultimate economic gold rush. It's an opportunity set to completely rewire the US and global business landscape as we know it.
But wait, here is the massive contradiction. You fast forward a year, and Goldman Sachs comes back to report that only 4% of U.S. firms had actually integrated generative AI into their daily workflows. 4%. So the trillion-dollar promise is absolutely there, but the actual rollout, it has completely stalled out. So what exactly is going on here? Let's dive into Section 1, the AI adoption paradox, why raw intelligence is fragile. The gap between the hype and reality, it entirely comes down to the system. Look, a raw model, something like the Opus 4.6 API, is unbelievably intelligent, but on its own, it's actually incredibly fragile. It just cannot do reliable autonomous work. Enter the AI agent harness. This is the software infrastructure that physically wraps around the model. It provides the tools, the memory, the permissions, and a strict step-by-step execution loop. The brilliant Mitchell Hashimoto hit the nail on the head when he pointed out that looking ahead to 2026, when an AI makes a mistake, you aren't just going to tweak the prompt anymore. You upgrade the harness itself, so that entire class of errors literally never happens again. Now, people get this mixed up all the time, but a harness is not a framework. Think of a framework, like LangChain or Llama Index, as the basic equipment in a commercial kitchen. It's your stove, your knives, your ovens. Having a state-of-the-art kitchen doesn't magically guarantee a delicious meal, right? The harness is the master chef's recipe. It's the routing, the logic, the rigorous quality checks. The harness is the actual workflow that guarantees a 5-star result every single time. And the real-world impact of a good harness is absolutely staggering. A joint study between Stanford and Tsinghua University just found that the exact same AI model can perform up to 6 times better simply by upgrading its surrounding harness. Think about that. The core intelligence didn't change at all, just the scaffolding around it did. This means the future competitive advantage in tech entirely belongs to whoever builds the smartest system, not just the smartest model.
Which brings us to Section 2, the anatomy of the harness, the 6 core layers.
I like to think of this like the mechanical blueprints for a high-tech movie heist. Every single thing has to execute in perfect sequence. First, you have instruction, setting the baseline rules of engagement. Second is context, rigorously managing what the AI is allowed to see. Third, tools, granting it physical abilities to actually run commands. Fourth, the loop, the engine orchestrating every single step. Fifth is memory, storing the state of the task. And finally, control, the strict safety guardrails that ensure an AI doesn't, accidentally delete a live production database. But making these layers actually work together is a total engineering nightmare. Take the context layer, for example. A recent UC Berkeley paper flagged this massive issue they called context rot. People think that just throwing a million token context window at an AI is going to solve everything. It doesn't. If you drown an AI in noise, old logs, and irrelevant files, it basically develops context anxiety and rushes to finish the task poorly. A brilliant harness prevents this by acting like a smart human developer. It writes massive files to disk and only gives the AI a tiny 8-kilobyte preview first. Then you've got the memory layer, which introduces this dangerous little thing called the stale but confident problem. I mean, memory sounds great until it's wrong, right? Imagine an agent relying on an old note about a company's codebase, completely missing the fact that a human developer refactored that code yesterday. The agent is going to confidently deploy a totally disastrous fix. That's why a serious harness treats memory with deep, deep suspicion. It treats logs as helpful hints, not absolute facts, forcing the AI to verify the live environment before making a single move. To enforce that kind of strict verification, Anthropic designed a super elegant solution, the multi-agent harness. Look, large language models have a terrible self-evaluation bias. Simply put, they always think their own work is flawless. Anthropic fixes this massive ego problem by separating the roles. You have a planner agent that expands a prompt into a spec,
a generator agent that actually builds the code, and a completely separate, ruthless evaluator agent acting as strict quality assurance. They are constantly checking each other's work, creating a highly reliable, bulletproof workflow.
All right, Section 3, Retrospective Harness Optimization, Agents Building Agents.
Okay, this is the real whoa moment of the explainer. Researchers aren't just building harnesses for AI anymore, they're literally letting AI agents study their own past failures to upgrade their own systems. Using a method called RHO out of Microsoft Research Asia, the system diagnoses its own failures and proposes updates to its tools and instructions. The result? A massive jump in coding performance on SWE Bench Pro, climbing from a score of 0.59 to 0.78 on a base GPT 5.5 model. And they didn't even touch the model's underlying weights. The AI just learned how to build a better environment for itself. Wild, right? And honestly, this evolution is exactly why generic, off-the-shelf agents just aren't going to cut it for real enterprise adoption. Major tech firms globally, and especially in the US, are pivoting hard to custom enterprise harnesses. A corporation is going to build a bespoke internal framework where the AI has frictionless, read-only access to very specific databases, but faces strict human-in-the-loop restrictions for security and bash commands. It's all about perfectly tailoring this invisible structure to a company's exact operational reality. Which brings us to Section 4, the final paradox. Will infinite context eventually kill harnesses altogether? Let's play devil's advocate for a second. If an Opus 10 or, say, a GPT-7 model eventually achieves a 100 million token context window, never loses focus, never suffers from that context anxiety we talked about, and is inherently smart enough to strictly manage its own security, do we actually still need a complex external harness? Is harness engineering just a temporary bridge patching the flaws of today's AI? Or is building this strict external scaffolding the permanent, forever foundation of autonomous software? It's a massive debate in the industry right now, and honestly, I want to hear your take. Let me know where you stand in the comments below. Thanks.